Hi there, welcome to your Unit 5 study guide. Just full disclosure, I'm gonna close that. This is our special guest. This is my cat Henna, and she is sitting on my lap, so she's really in the way. She doesn't understand. Whoa, and she's gone. Okay, well, there you go. But she might be back. My other cats that I had used to make quasi regular appearances in my videos, and if you've watched them, you've probably seen them. Henna is younger, and I unfortunately no longer have the other cats. So just heads up, there's a cat around. She's cute. All right, so we have our Unit 5 study guide, and without further ado, let's go into what do you need to know for your quiz. So know the shape of different families of functions. So to review, try sketching the shape of each of the following types: absolute value, quadratic, linear, exponential, and square root. So we'll go through those together. So absolute value we have looked at. Absolute value graphs are the ones that are shaped like V's. Okay, so that's what that family of function is. A quadratic, I think we spent plenty of time on those. There's a lag between when I'm writing on the little tablet here and when it appears on the screen. Oops. Um, so that's good. There we go. So the quadratic is the parabola, and of course, these can also be flipped over, so we could have a reflection on those. Linear, okay, linear function graphs to a line of some sort. Exponential is the new one, and you should have in the lesson explored what exponentials look like. So a parent exponential will look like this, where it looks like a flat line for a while, and that was not good. Yeah, let me try that again. So let's try this again. So it looks like a flat line maybe for a long time, and then it curves up, and when it starts to curve, it gets steep very, very fast. So a characteristic of exponentials is something called an asymptote, meaning that there is a horizontal line, and it's going to get closer and closer to that line, but never actually touch that line. Okay. So that would be an exponential. Now you can also reflect these around, so you could reflect them over the y-axis so that they look like that, where like they start out going down really steep and then they look like they level off. And you can also like flip them over, so you might get something that looks like that. Okay, so like different ways that you can do that. Now, a square root function is, if we were doing these units in the order that we used to do, the square root function would be one that you would be familiar with. Now, here's the deal though. Of all these functions, this is the only one you haven't seen. So if it's something where you just have to like match them up, this is the one you don't know. But so that you guys have it, the square root function looks like this. It is actually the top half of a sideways parabola. So if you took your parabola, put it on its side, and then only took the top part of it, or only took the bottom part of it, that would be your square root graph. So definitely I would write that down. Okay. Now in a pinch, you could like graph y equals the square root of x on Desmos, and you could take a look at it. But no, so there you go. Those, and this is just recognizing the family. So when you see a relationship and you see what it looks like, or you see a certain kind of curve, that you know which category of function it falls into. Next one, describe the transformations given the parent function. So this would be like, here's your parent. Okay, so we have y equals 3 to the x, and you would be asked like, what are the transformations on y equals negative 3 to the x minus 2. Well, we know that a negative out in front will reflect it. And this is actually a reflection over the x-axis. So we could say reflect or flip is fine. Flip over x-axis. and subtracting a 2 on the inside of the function will send it right 3 units. Looking at this one, okay, the negative here will flip it over the y-axis. And the -4 outside the exponent will make it go down 4. Okay, so just recognizing the transformations. So like you're given a function and then maybe you have to list what the transformations are. Next one. Now, be able to solve exponential equations by writing each side as a power of the same base. So for example, solve 4 to the 2x equals 8 to the x minus 3. If the directions say to solve this way, other methods will not be accepted. So you do have to follow the directions. Once you have taken and passed your test on exponentials, no one actually cares how you solve it. But when you are demonstrating your knowledge and your skill in a specific area, then yes, like we want to see, can you use the different tools? So the first thing I usually tell you guys to do on this is to see if, let me go ahead and copy the problem over. See if you are able to write the larger number as a power of the smaller number. So you might do some scratch work over here. 4 to the first power is 4, and 4 squared is 16. And we were looking for an 8. Oh no. Okay. So basically there's no power of 4 that will give us an 8, at least not something that we can find quickly. So when that happens, then you have to go to a smaller number and you have to think, okay, is there something smaller than a 4 and an 8 that I could write both the 4 and the 8 of powers of? And the answer to that is yes, we could pick a 2. So 2 to the first power is 2. 2 squared is 4. So there's our 4. And 2 to the third is 8. There's our 8, so we have them. So coming over here, we are going to do a substitution. And instead of 4, I am going to substitute 4 with 2 squared, which isn't exactly how I wanted to do that. I mean, it's fine how I did it, but I want to be consistent with this. So we're going to replace that with 2 squared, like so. And then in class, when I taught this, I talked about the super cool exponent club, where the 2x was in the exponent and they're not accepting new members. They're just not going to accept new members. And so they put up their walls and say, no, you're not sitting at our lunch table. No, no, no. Okay, we're not accepting the new 2. Over here, we're going to take the 8 and replace that with 2 to the third power, but we have the same issue. We have that the exponent that's already there, and they're not accepting applications for new members. Okay, so now what that's going to do is it's going to help avoid an order of operations issue by just putting up the super cool exponent club walls. And now we have a situation where we have the same base, okay? And so you have 2 to something equals 2 to something else, which means that these two things must be equal to each other. That's the only logical conclusion to draw there. And so we are able to, at this point, basically ignore the bases and we can just set the exponents equal. And you are welcome to multiply when you do this. Okay, I won't for the purposes of the study guide, but okay, so 2 times 2x is 4x. And then over here, we're going to distribute. And so we have 4x equals 3x minus 9. So we'll go ahead and take away 3x's or subtract 3x's from both sides. 4x minus 3x is 1x. 3x minus 3x is 0, leaving us with the negative 9. That should not be more than 1, 2, 3, like 4 steps. Okay, that's basically a 4-step problem, and that's probably the hardest version of that I can find to give you. Anything else would be easier than that. It would only involve changing one of the numbers instead of both of the numbers. So this one definitely shoots a little bit higher than the base level. Now, this is fair game. Anything that's on your study guide is fair game for your test. But this was the highest of the levels of this that I could give you. All right, be able to solve exponential equations using logs. Student laptops will be restricted to Desmos only, or you can use a handheld calculator. If you do not have your student laptop or cannot use it, I have a computer near my desk that you can access, or you can use one of the engineering ones. But no, you may not, first of all, you have to have a calculator to do this. All right. Like there's no way to do it without a calculator. So here we go. So to solve an exponential equation, your first step is to isolate the exponential. Okay, exponential. So we'll take a look at this first one. So we have 2 times 3 to the 2x minus 1 minus 4 equals 10. And so we're really clear on what is the exponential. The exponential is the base and the exponent attached to the base. So in this case, it's the 3 and the 2x minus 1. And then what we need to deal with is we need to deal with that minus 4, and we need to deal with that times 2. And we cannot do 2 times 3 because the exponent only goes with the 3, not with the 2. And so that's an order of operations thing. All right, so to do this, we would add 4 to both sides. I recommend adding the 4 to both sides before you divide by 2. So plus 4 and plus 4. Sorry, that lagginess is really bothersome. So 3, 2x minus 1. And so negative 4 plus 4, of course, is 0, and 10 plus 4 is 14. And now this is multiplication, so we would undo that with division. So we get 3 to the 2x minus 1 is equal to 7. Now we have it in a form where we can change it over to a logarithm. And so for that, I'm going to go up to the top of the screen here. We know that a base raised to an exponent, if that's equal to a number, then that is equal to, or can be rewritten as log base b of n is equal to the exponent. And so for this one, we'll have log base 3 of 7 is equal to 2x minus 1. And this is why you need a calculator, because there is no other way to evaluate log base 3 of 7. Now, for most of you, you're going to hop onto Desmos. You're going to go into where it says log base, and you're just going to type in log base 3 of 7. Some of you are probably going to opt to use a handheld calculator, in which case you would need to use the change of base formula. And I'm kind of out of space. So I'm going to try to move over to the right, but no guarantees here. So if you need to use the change of base formula, that is the log of the attic divided by the log of the basement. Okay, whatever that is. And I think I do need to do that for the calculator that I am using. So give me a second. So we have the log of 7 divided by the log of 3, and that gives us 1.771. So 1.771 is equal to 2x minus 1. And from here on out, it's a two-step equation. So we'll go ahead and add 1 to both sides. I do strongly recommend that you use a calculator for this. This isn't too much of a problem like the adding of the 1. It's when you're subtracting. I see subtraction errors all the time, and they, because students like think they can do it in their head, they think it's really obvious, and it's not. And so yeah, just please do that. Okay, and so add 1, and I'm going to divide by 2, and I end up with 1.3856. We'll do 3 decimal places, 1.386. Okay, and there is our answer. And okay, so there we go. Now that's a longer problem. That was a 1, 2, 3, 4, 5, 6. That was a 7-step problem, maybe 6 steps. if you're not using the change of base. Definitely a longer problem. If you felt pretty good about it, then the day we did this in class, it's always good. It's always a good class day. Like I just don't have issues with students like the day that we do it. But something happens between the day that we do it and test day that it can become a little bit weaker. All right, the one we have over here. So here's our exponential. So we need to isolate that. So we're going to start by subtracting the 3 from both sides. So we have e to the negative x plus 1 is equal to 5. And now we'll go change it to a log. This is log base e of 5 is equal to negative x plus 1. And of course, we do want you to skip over that log base e. That's not something that we really want you to be doing. Yeah, the whole time. Now at this point, I always recommend go ahead and evaluate the log. Now you could subtract 1 and then divide by -1. You could do that and get an exact answer. But if it doesn't ask you for an exact answer, I would evaluate the log. So the natural log of 5 is 1.609. 609. And that's equal to negative x plus 1. We need to subtract 1 from both sides. So we'll get 0.609. Now, this is a little bit weird. That is not exactly what we wanted. We've got negative x and we want positive x. So you could think of this as one of two ways. You could multiply both sides by -1, or you could divide both sides by -1. I don't care. And you don't even need to show it. Okay. Like that you do not need to show. And so we end up with negative 0.609 is equal to x. And there's my answer. That one was a 1, 2, 3, 4, 5, another 6-step problem. Maybe 6 steps, if you do the log base e. Okay. So longer, not crazy insurmountable long, but if you think that these are going to take you a longer time to do, I want you to strategize appropriately. So you might want to skip over these and do something that's shorter to do. All right. Be able to expand and collapse logarithmic expressions using the properties. So we're going to expand this one. Now these are doable in one step. If you photomathed your way through the homework on this, this is where it's going to come back to bite you because now, so I can do this in my head. So I'm going to say this is 2 log base 3 of x minus 3 log base 3 of y minus log base 3 of z. You're like, oh, how did she know how to do that? What was she doing? This is crazy. Okay, so let's see how I get from one spot to the other. And you do not have to show work because they are doable in your head. So we do have division here. And division will expand into subtraction. So we'd have log base 3 of x squared, that's the numerator, minus log base 3 of the denominator. Now, this could get a little bit tricky. Okay, so we have y to the third z. This is multiplication. And so if you just expand that out and say, okay, that is multiplication, you're going to end up with a plus sign where you don't want it. So I'm going to do this. I'm going to put a big grouping symbol there. And what that is to say we are subtracting this whole thing. Okay, we are subtracting that whole thing. Okay, sorry about that. I had to respond to a text message. Okay, so let's go ahead and resume with this. So we got these big brackets here. So if you have multiplication, that will expand into addition. So you have log base 3 of y to the third plus log base 3 of z. Oh, my big bracket there. And then notice this. When you, well, let's go ahead and bring our exponents down. So we've got the 2 that's going to come down in front of the logarithm of the x. And then we have the 3 that's going to come down in front of that log with the y. And then we don't have anything to bring down here. Okay, notice that this subtraction goes with the whole thing. So it's going to be minus 3 log base 3 of y, but it's also minus 3 log base 3 of y minus log base 3 of z, which is where that other minus comes from. Now, the way I did it when I was like kind of thinking my way through it, like how can I do this, is I know from experience anything in the numerator is going to be positive or adding. Anything in that denominator is going to have subtraction. So the y to the third is going to be subtracted. The z is going to be subtracted. This is just how you get there the long way. Again, you do not have to show work for this, or you could show any amount of work in between. Will be fine for that. Second one is a collapse, and a friendly reminder that these are L's. I have not, oh, and this is missing. This is supposed to have a Z there. I have not yet taken off points for people writing INs, but I totally will on your test. So it is an LLL for logarithm. All right, now again, this is doable in one step. So I have a positive x, so that's going to be in the numerator. I have the negative for the 3 ln y, so that'll be, the y will be in the denominator and the 3 will be in the exponent. And then this is being added, okay, which means it's going to end up in the numerator, and the 3 will end up being the exponent on the z. And that's how I would do that, just in one step. Now, if you're doing it in multiple steps, let's see how we get there. We're going to take those coefficients and bump them into the exponents. Okay, so that's where the y to the third and the z to the third come from. If you are subtracting logarithms, then they would be written as a quotient or division. So the first divided by the second. And then if you are adding, you would write it as multiplication. So, and then this is one of those things, if you're multiplying, and I think we did this in class, you have like z to the third, it's over 1, which means it's in the numerator. So you can do that out. Now, technically, I would have to give you full credit for the line above, but please don't leave it like that. Okay, so expanding and collapsing. And remember, partial credit is always on the table. So if you can get partway there, then give me partway. If you can, just, if you know what to do with the exponents and you're totally at a loss with the adding and subtracting and multiplying and dividing, just give me the exponents. Like, give me whatever you got for expanding and collapsing with the properties of logs. Okay, be able to solve logarithmic equations, including using the properties of logs. So we have a couple of log equations here to solve. We have 4 log base 2 of x. And you know what? I'm going to throw some extra credit into this video just for funsies. For extra credit, hop on into Teams and post. Let's see, I'm thinking like the year that I'm doing this. Post either that you do not have a pet, or post like what kind of a pet you have and your pet's name. So I would post like, I have a cat named Henna. You might post, I have a dog named Fido, or a hamster named Jerome. Okay, whatever you have. Or if you do not have a pet, just say, I do not have a pet. And just go and post it in the like questions, class discussions, like wherever we have the channel for. You guys should just go into questions, make class discussions, like you're going to start a discussion about your pet. All right. So thank you for watching the video. Go on in, make that post, and I'll throw in some points for you. Okay, so what we have going on over here, we have 4 log base 2 of x plus 3. Now, there's a couple things you could do here. So let's say you start this and you're like, oh, well, I know what to do with that exponent. I'm gonna copy the problem on. Don't do that. Okay, don't copy the problem on. Okay. And you're like, okay, I can move that into the exponent. And then I would have 2 to the 12th power equals x. Yeah, okay. And then you look at this and say, I don't know how to solve that. Now, if this happens on the test, use your calculator, get 2 to the 12th power, and then you're like, I stalled out. Okay, you don't erase it. Do not erase it, because there would be nothing wrong with this work. It's just you kind of stalled out in a spot. Now, given that, we might be able to see something else to do. Okay, let's see. There we go. Just delayed there. So what else you could do, though, is you might recognize that this is multiplication right there between the 4 and the log. And so you can undo multiplication with division. So that would give us log base 2 of x plus 3 is equal to 3. And that looks much, much nicer. So now we're going to use this again. Remember this, we had this up on the other slide, that changing of the form. So that's log base b of n is equal to x, only now we're going to be going in the other direction. So we'll have 2 to the 3rd power equals x plus 3. 2 to the 3rd power is 8. And then to solve for x, we subtract 3 from both sides. Okay, so yay on that. Now you can do it the other way, and in years when we've done the units in a different order, you would have a skill set that you would be able to do it the other way. You could take a 4th root and then use your calculator. You have this enormous number. It's doable the other way. This is still the better way to do it. All right, over there on the right, we have 4 logs. We have like a log bonanza. So now there's a lot of things you could do with this. What you cannot do is just cancel out the logs and say x plus 5 equals 20 minus 4. Like that isn't a thing. But we do know how to add logarithms, and we know that if we have a 2 logarithms that are being added together, we could write that as a single logarithm and multiply the arguments at x times 5. And if we have 2 logs that are subtracted, we could write that as a single logarithm and divide the argument. So that would be log of 20 divided by 4. Now, once you have the same log on both sides, you could do some voodoo here and like subtract, and you'd make it hard for yourself. But basically, whatever you do to one side, you do to the other side. So if we're going to unlog this side, then we unlog that side, whatever that means. And I'm just going to change that from x times 5 to 5x. And this is 20 divided by 4, which is 5. And then we divide by 5 and get x is equal to 1. Now, neither of these problems were super, super long. So this was a 1, I'm looking on the left here. This was a 1, 2, 3, 4 step problem. This was a 1, 2, 3 step problem. And so that gives you an idea of what you could see on your test. Yeah, so nothing massively longer, and probably some pretty simple problems as well. So if you're really stuck in the mire, it means you missed something that you could do that would make it easier. All right. Given a sample of work, be able to identify what the error is. And so I don't know what we could do here to give you an example. So you might have 2e to the t plus 4 equals 6. Okay. And so somebody does subtract 4, and we're cruising along. And then they're like, subtract 2, and and then they're like ln. Okay, it goes on, and you might recognize, ooh, right there, that's wrong. Okay, and so a couple of things you can do. You are going to have to explain what's wrong, and so in this case, you might say something like, the 2 was subtracted when it should have been divided. Okay. That would work. You can also highlight, that's not the same as explaining it, but it might help your explanation. So you might like highlight in the, maybe not with purple though, like not with purple. Let's go back to yellow. That you might highlight, where the error is. Don't just tell me it's wrong. Okay, just that no, like you don't just tell me that it's wrong. Like I know it's wrong. I want you to tell me what the mistake was. And it's always better too if you can tell me what should have been done, but you don't have to do it. Okay, so you don't actually need to do the problem. Just like the 2 is subtracted when it should have been divided. The 3 was multiplied when it should have been divided. The 2 was, I don't know, the base and the argument are switched when we converted it to a logarithm. Like whatever the mistake is, be able to identify it and explain what it was. And lastly, be able to solve problems involving interest. So this is new this year that it's actually going on the test. And to be totally honest, I just wrote this problem. I have no idea how it's going to come out. So if Stephanie wants to have $5,000 in 3 years, how much would she need to invest if her account makes 1.5% interest? And then this is compounded continuously. So our strategy is write down everything we know. She wants to have 5,000. So that means at the end, she wants to have the 5,000. So that's your A. The amount of time she's investing it is 3 years, and her account makes 1.5% interest. Remember that that should be written as a decimal. And the question is, how much would she need to invest? And so the thing that we don't know here is the principal. The equation for this is A equals PE to the RT. So you would write down your equation with nothing in it, and then you're going to show me where you're putting in the numbers. So we've got 5,000 is the ending amount that we want. We do not know P. We have E, our R value is 0.015, and RT is 3 years. And so on my calculator, I am going to find out what that is. And it's a very poor lighting in here because it has gotten dark while I've done this. E to the 0.015 times 3, close parentheses. That is 1.046. 1.046. And then we'll go ahead and divide both sides, and we're going to find out how much does Stephanie need to invest. So 5,000 divided by 1.046, and we get $4,078.11. $4,780. Sorry, I said it wrong. 11 cents. Okay, and round to the nearest penny on that. And you could see any variation on these. So you could see the solving for the amount, solving for the interest rate, solving for the time, so like anything. Okay, so you might have to bust out your logarithms to solve it. And let's put another extra credit point in there just for fun. Let's put in, I want you to go on to, well, no, let's do this. On your actual test, I want you to draw a face somewhere near your name. Okay, just a face somewhere near your name. Okay, that's it. All right, and you can pretend like you're doodling so your neighbor doesn't know what you're doing. All right, so I was able to keep this under 35 minutes. Hopefully you watched the entire thing. If you've got questions, try to email me or post on Teams before the day of the test. That way I can prep a review a little bit before I hand you guys the test. If you spring it on me at the moment, that's a lot harder for me to try to figure out like what's a good review problem to do. So as always, you guys know how to reach me, and good luck on test day.